Hello guys. Okay. Hope you have all done with the this weekend project, right?
Yes, ma'am.
Isha, can you just switch off your mic? Isha. Okay, guys, all of you have done with the project, right? And you have submitted the project as well.
Did not submit, ma'am.
Not submitted, ma'am.
Okay, then you submit the project by today. Okay, by today day end. Make sure that every one of you must submit the project to the same like mini project that mail ID that has been given to you. There you have to submit the project without fail because that would be go for further evaluation, right? So what's the point? You have done the project, but that not got evaluated, right? So you need to just submit the project accordingly. Okay. So by today, after the class, make sure that each one of you submit the project. Fine.
Yeah, ma'am.
Guys here. Okay.
Ma'am,
Okay.
like the last
So
project we submitted on mail, in that way we have to submit?
sorry. Yeah, Didi, like the same one, like last project, week one project, how you have submitted in the very similar way, you have to submit this project as well. Okay.
Okay, ma'am. Thank you.
And okay, and each one of you have to submit the project. So I guess everyone is ready with today's project, right? So today we will be going ahead and you have to present like the this week project, like week two project.
Yes, ma'am.
Okay, fine. So let me know who all are ready, so they will present the project. So who
I'll
wants to
start if you
present?
permit, ma'am.
Okay, fine. Okay, Fida. Then after Fida, who wants to go?
Ma'am, can I?
Yeah, definitely Aditi. Okay, after Aditi. Sorry, are you people not ready with your project or what? Garima, you are saying something. Can you be a bit louder? I am not getting you. Garima,
Can I present?
okay. May I know your name, please? Who wants to present? Please let me know your name.
Ma'am, I want to present.
Chetan. Okay.
Ch-
Chetan. Okay. Okay. Next. Am I not audible to you? Guys,
Yes, ma'am.
so why you people are not responding? Are you not ready with the project or what? No one is responding. How come this will happen?
Can I present after that?
Okay. Soumya, you can present next. Next, after Soumya, who wants to present?
Ma'am, can I?
Okay. May I know your name? Just let me know your name.
Ma'am, Sajruddin.
Okay. Okay.
Hello.
Yeah.
Ma'am, do we have to present second week project today or the first?
Yes. Second week project.
Uh, I can present today.
Okay. 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 Fine. Next, you present. So, we'll start off with today's presentation then. Okay. So, Fida, you are ready, right? So, you just like share your screen and start presenting.
Sure, ma'am. Thank you.
Okay. And just one thing, you don't have to explain each of the code line by line.
Okay.
Just explain the objective, the details, and accordingly goes like what you did, like importing libraries and stuff. You can tell, but don't have to explain the code line by line. But try to explain it like as vividly as possible, right?
Okay, ma'am.
And try to like put in more stress or intent towards if like this year this week project are you been given with EDA.
Sorry, ma'am, I didn't get you.
This week project you have been given with EDA. I just wanted to ask.
Yeah, ma'am. EDA and hypothesis
Okay,
testing along with the interactive visualizations.
great. Okay, fine. So just put more emphasis on the insight that you have got from the graphs or plots, and accordingly just go ahead. Okay.
Okay, ma'am.
Okay, great, Fida. You can continue.
So, good evening, all. My name is Fida, and today I'll be presenting the project I chose, the diabetes risk analysis. Here, I've used exploratory data analysis, hypothesis testing, and interactive visualization, which was excuse me, just a minute, ma'am. I'm extremely sorry. I've got a lot of disturbance here.
Okay, no, not an issue. You can continue.
Okay. So, yeah, this was the syllabus of past 2 weeks we had. The like personally, to be honest, the reason I chose is myself being diabetic. I would love to explore more about the disease. So, and the main objective here is to understand what health features are main predictors of diabetes in recent years. And yeah, that's what, to explore the relationship between features and the presence of diabetes or not. And we validate the findings from these EDA by hypothesis testing and providing insights for the like for improvement in the medical research. Business context here is like we on early detection we can build preventive measures, and predictive modeling in healthcare centers on machine learning will be helpful. Next, the data source is from a PIMA dataset which was posted on machine learning UCI repository. The data overview here is um, the main objective of the data here was to predict whether a patient has diabetes or not based on some health measurements. There are some numerical values like glucose, BMI, age, and these detects whether a individual has diabetes or not. And the population of this diabetes recordings are of women of PIMA Indian heritage, and all of those records of people are 21 years above. And it is collected by NIDDK, that is National Institute of Diabetes, Digestive and Kidney Disorders, and was posted on UCI repository. Here, the data has binary classification. Overall, the outcome has two classification, either diabetic or non-diabetic. So it is called as binary classification. Data pre-processing I've done is, of course, the data collection. This data consists of 768 patient records and 8 features. They're dependent on the target variable here 0 or 1, and yeah, the target variable 0 or 1 here, and 8 independent variables means 8 columns, and plus 1 column, there is a total of 9 columns. Yeah, all patients are PIMA Indian women aged above 21 years. And next, data cleaning, like replacing invalid zeros with none, and handling missing values, and detecting duplicates and dropping them. Next, feature engineering, we have created age groups and like pregnancy bins, like how many pregnancies are, and this 20, 10, 20 to 30, 30 to 40 age groups as such. And the BMI and glucose, when we combine these two, and how it shows the outcome. Techniques, of course, univariate analysis, bivariate analysis, multivariate analysis, and correlation heat maps, hypothesis testing. Ma'am, do I need to explain this, or
Which one? I didn't get you. Like, which one you need to
all these,
explain?
ma'am, like univariate and bivariate, multivariate?
You have gone ahead and plotted the graph, right?
Yeah, ma'am.
Okay, you just this is the structural how you have put it in, right? So you don't
Yes,
have
ma'am.
to put more stress up here. You go down while you'll be showing each of the plot or the graphs. You just explain accordingly and also give more stress towards the insight that you have received from the plots, right?
All right, ma'am.
Okay.
So, so firstly, importing the libraries. Here, Plotly is the library for interactive visualizations, and the stats for hypothesis testing, and the rest for visualization, plotting, and numerical operations. Next, importing the dataset. I've downloaded and uploaded the dataset into my GitHub account, and from there I'm importing here. And next, I'm creating a copy of the original dataset, because I it's good practice, because whenever we do feature engineering or delete rows or columns, so the original data should retain its value. So we have created a copy here in order to perform every operation on the copy of the data set. Then, yeah, and next I'm checking here whether the copied data set is as same as the original data set. um, it looks same. Next, the first 5 rows. Here we can see there are all the values here are numeric: pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function. This is like genetic value, age, and the outcome. 1 and 0 is the outcome. So last 5 rows. And here I've taken this, the sample function, inbuilt function will take any random five, because I've mentioned here 5, it will take any random 5 rows from the data set. Here we've got random. Next, this shape. So the data frame has 768 rows and 9 columns. 8 are the predicted columns and 1 is the target column at the end, the outcome. And this is about the features, the columns. There is all of the data, most of them are integer data types, and float are BMI and diabetes pedigree function, and all are non-null. Total unique values in each column. Unique column in the outcome, it must be 2, that is 1 and 0. Null values, yeah, there are no null values here, the data is clean. And visualizing this using missing numbers here, since there is no null values, there is no white lines in the plot. And the same thing, I'm using a heat map here. The same reason, since there are no null values, it is solid single color. If there are null values, there will be two bold colors, and one indicates, the lines indicate the null values in the region where it is plotted. Then finding the duplicates. And if there are any duplicates, we are dropping them using the drop duplicates function. So there are no duplicates in the data set. See the data columns. This is of the original data set, and this is a copy of the data set. I've displayed both. Describing the data set. Here you can see uh, minimum and maximum, the count, the mean of this is a mean of pregnancies. Maximum pregnancies are 17, minimum pregnancy is 0. For all the columns and features, we have the um description here. So what did we know about the data set here is there are 8 medical predictors except the outcome, the target column. Every other column is a predictor of whether a patient has diabetes or not. And one target outcome, if it is 0, it is non-diabetic, and if it is 1, they are diabetic. So this focuses on health attributes, like whatever features are main influence of diabetes risk in specific group. That is, here we have taken women around above 21 years of age. So and the purpose here is used to analyze risk factors, as I told you, and the patterns in the health data. It will help in to build predictive models for early detection of diabetes. Value, it is like today's most concern is health, so it is highly widely applied in medical researches and machine learning education. Like we build predictive models, that's education for AI/ML engineers, and predictive healthcare solutions. So, like I told you, the problem statement here is diabetes is, of course, growing global health issue. 1 out of 10 is detected by diabetes. So, early detection of diabetes and treating them with proper predictive healthcare solutions can help uh, early detection and diagnosis. So, here we're detecting the outliers. So this function, we are using interquartile range to detect the outliers, and then we'll treat it by a process outlier treatment called capping. This is it is not much like critical. Very simple logic here is, uh, if we have upper limit and lower limit in the calculation of outliers, so if the value of the outlier is above upper limit, and it is replaced by upper limit value, and if it is lower than the um, lower limit, it is replaced by the lower limit value. This is done for data set with very less rows. Like for example, within 1000, if we drop, there's another method of treating outliers is that we can drop off the rows, but in such very less data, if we drop off the rows, we may lose the um, data of which we can gain from that. We may lose some information. So capping is more preferred here. And then visualizing after treatment, we can see the box plots. There are no outliers here. Outliers were mainly occurred in insulin, skin thickness, and BMI. So most of the outliers in the data set were in insulin, BMI, and skin thickness features. So we used IQR here. They were detected, and the treatment was capping. And this is the explanation I've added for capping. Capping treatment is also known as vincerization. Like the outcome distribution of the outcome distribution, that is distribution of diabetic and non-diabetic people. So the count of non-diabetic is 500 among the data set, and 268 of the women are diagnosed as diabetic. So this was, 65 are non-diabetic and 35% were diabetic. Univariate analysis. Here, for every column, I've plotted the histogram to look at the distribution of the count. Yeah, so this is the distribution of pregnancy. So it goes column by column. So what this shows is pregnancy. If they have 2 pregnancies, the count is this, and like uh, 4 pregnancies, the count is 68. These are the interactive visuals I have used using I've plotted using Plotly, and this is distribution of glucose. Higher the glucose and count is also higher. The glucose level 100 to 119, count is 94 as such. Distribution of blood pressure, the similar logic goes this, the value of blood pressure is this, and the count is around 70, no, 153, sorry. Distribution of skin thickness, distribution of insulin. So here we can see where there is zero insulin, zero value of the insulin, the count is higher. The rest, when the insulin level is high, here 250, the count is only 5. This is a lesser value, we can see. So glucose, insulin, and BMI. BMI and insulin, they show skewness, like there are outliers here. Can say BMI, there are many outliers here. This way here. So we've already treated the outliers of insulin and BMI. Here this that was histogram, and here I'm using box plot to visualize the outliers basically, and to see the distribution. Since we've treated outliers, there are not many here. We've treated outliers in specific, like the most influencing features. This, so the box plot shows the distribution of count. Outliers detected in insulin and skin thickness. It is not showing outliers here because I have already treated the outliers in insulin and rest of the columns, so it is not showing here. But without the treatment and detecting the outliers, it would show us the outliers like this, similar to this. These are the outliers from the box plot. Next is the bivariate analysis. So here BMI versus glucose by outcome. So through this scatter plot, we can see this side is the glucose and BMI. The BMI, the higher the BMI and higher the glucose, we can see this yellow are the diabetic and blue are non-diabetic. So the population of diabetics are more, they're scattered more in more value, higher value of BMI and higher value of glucose. So higher values of glucose and BMI indicate that there is a risk of diabetes. Diabetic clusters at higher BMI and glucose value. This is the insight from the scatter plot above. And here there's a violin plot in Plotly. Why it is called violin plot is you can see the shape of the plot is of violin, and here it is different for the outcomes. Like for non-diabetic, zero outcome, it shows the distribution, and for the diabetic, um, the one outcome, it shows the distribution. Here we can see the non-diabetic are the cluster is higher in the BMI range of 20 to 30, and um, there are more count, of course, of non-diabetic in the data set, where we can see the diabetic here, the cluster is more in around 30 to 40 BMI range, the cluster here. And is, yeah, for glucose, the cluster is more for non-diabetic. The distribution around 50 to 100, 120, the cluster is more when the glucose value. And when the glucose value goes higher, the cluster of diabetic patients are also higher here. Same goes with all the other columns I have used. Every eight features, every eight predictors are being plotted here. Next, the correlation analysis. Yeah. By this correlation heat map, we can see when we compare the values here. Yeah, the glucose here has higher value compared to others. Like it's 0.466 something, and BMI 0.3. Compared to other correlations, BMI and glucose are highly correlated with the outcome. Multivariate analysis. So these are the pregnancy counts here. So people with 6 pregnancy, the total count is 50, in which this count 34 of them have 34 of them are non-diabetic, while the yellow line here 16 of them are diabetic. So similarly goes with all of these pregnancy values, where pregnancy value is 1, people with one pregnancy, there is total count of 135 people who have gone through single pregnancy, and in them 106 are non-diabetic and 29 are diabetic. I hope you all got how this plot explains. So older, sorry, scatter plot. This is a 3D scatter plot I have used from Plotly, of course. It uses three indexes here, three axes to look at the distribution. I've used age, BMI, and glucose. And how is the distribution? It is interactive, of course. There's a group analysis. Like I told you, the feature engineering we did is we made age groups and pregnancy bins. Here is the age group. The age group 40 to 50, how many are diabetic and non-diabetic? So in the group 40 to 50, diabetic count is 64 and non-diabetic count are 49. While 30 to 40, there is 76 and 81 are non-diabetic. Age group 20 to 30, non-diabetic count is higher, whereas the diabetic count is 90. So comparing this, we can see that there is higher count in age group 40 to 50. Here there is higher count of diabetes, but compared to the non-diabetic, it is very less. So when we merge them and calculate, uh, around age 40 to 50 people have mm, more, 30 to 40 and 40 to 50 people are more risk of diabetes. Here I've grouped pregnancy, like these are the pregnancy bins. So the probability and pregnancy. So if there are 8 pregnancies of for a person, then what is the probability of having diabetes? So it is based on the distribution, of course. We have just taken the probability value instead of the count. Yeah, you can see probability of diabetes increase with pregnancies. Higher the pregnancies, higher the probability value. So higher the risk of diabetes. Next, pair plots. This also shows the distribution of diabetic and non-diabetic people, but based on like they're plotted to each other, like insulin and glucose. What value of insulin and what value of glucose, and how mm, the data is distributed, how the people come in the uh, sector, which sector, whether it is diabetic or non-diabetic. And age versus outcome. Here, there is a hectic gathering here around 20 to 30. It is non-risk. They are non-risk of diabetes because it is outcome is 0, and the cluster is around 20 to 30. While the cluster goes of age 60, 70, 50, still there are lesser count of distribution. While we can see here this area above 30 has more clusters of diabetic patients compared to this, and this year there are less chances of diabetes, and here there are more. So this is age distribution by outcome. So diabetic patients, and this is the age distribution. So around 20 to 70. People of age 30 have diabetes, and the count is 42. 42 people who are around 30 to 34 age have diabetes. The showing data here will tell you exactly what the values are. Similarly, this is for non-diabetic. To the age 40 to 50, count is 32. They are non-diabetic. Next is a tree map. Here every feature has been shown as a tree. You can see the one, and these are the branches: 1, 2, 3, 4, 5, 6. It goes as a binary tree basically. So here this it shows that this this is diabetic, and this is non-diabetic, and this is diabetic. It shows the distribution basically. And this is higher, and this shows a smaller area. This is larger area it covers. Yeah, it helps visualize the contribution. It makes us easy to uh, visualize, easy to identify how the data is spread, how the data is distributed. So these are the box plots. This insulin versus outcome. So what values of insulin, what units of insulin shows which outcome, whether it is diabetic or non-diabetic. Here, of like the age where there is less insulin value, there are the clusters of non-diabetic, and the diabetic cluster ranges higher until the insulin value is around 180 to 200, like that. This is the cumulative distribution of glucose by outcome. So this you can see the glucose values here: 100, 150. Higher the glucose, around 100 to 150, the distribution is on peak. Diabetics consistently dominate higher glucose ranges. Next, scatter with regression trend line. So I've used glucose and age as the key indicators. So we can say higher the glucose, this higher glucose, yellow are the diabetic and blue are the non-diabetic. So yellow, the diabetic data is spread in a higher level of glucose, as well as age around 30 to 50. Between 30 and 50, there are more yellow plots. So this indicates With increased age and with increased glucose levels, the risk of diabetes is higher. Whereas the age around 20 to 30, there are more clusters and glucose around. There's a normal range of glucose, as per the studies, is 120 to 140 for non-diabetic patients. So these range lie between the same uh, depicted range, so they are at a lower risk or no diabetes for they have. Next, the hypothesis testing. Here the null hypothesis is the mean glucose in diabetic patients is 140, and the alternative hypothesis I've taken is the mean glucose in diabetic patients are greater than 140. When we perform the hypothesis testing, uh, the conclusion is we fail to reject null hypothesis. That means it is said that mean glucose in diabetic patients are equal to 140. So when a person is diabetic, even 140 is a higher range for them, and there is no significant evidence that mean is greater than 150. It is shown through the data that it is almost equal to 150, not greater. In the conclusions we have here, the key findings are as we compare all of the plots and the insights, we get to know that glucose, BMI, and age, body mass index, and age are the strong indicators of diabetes. Higher the glucose and age, as we saw, higher the risk of diabetes. Also, higher pregnancies increase diabetes risk. We saw that in histogram, hist plot, and age groups above 40 have a greater risk of diabetes. And correlation analysis shows glucose as most associated because the value of correlation was around zero point 0.4, which was higher than the rest of the values in the heat map. And the business impact, yeah, healthcare providers. So since we know glucose and BMI and age are the strong indicators, we can focus more on the glucose levels and BMI management in order to decrease the risk of diabetes. And also we can design awareness programs at hospitals or schools or any other gatherings to decrease the risk among the age groups. And researchers can use findings for machine learning models as to build predictive modeling and all. So that's all about my project. If you guys have any doubt, please feel free to ask me. I'll try my best to answer.
Okay, Fida, it was a nice presentation from your end. Like it was far more better, like expressive before, like in comparison of the first week. You have improved a lot. So
Thank
all
you,
the
ma'am.
best. Henceforth, you will be like we'll see you progress more in this regards. So
Thank
next
you.
we will, yeah, okay. Fida, you can just stop sharing. Next is Aditi, right? You can just share your screen.
Can I start?
Yeah, definitely. You just share your screen and start.
Yeah, sure. Uh, Hello, ma'am. Good evening. Myself, Aditi Chowdhury. So, I have choose the topic of mental health in tech professional, which is the EDA project. Basically, I have used this topic because in our current day-to-day life, we travel a lot, and due to which we are unable to talk to our close ones. Then which becomes some conflict into our mind, and the thoughts and the all the thinking we is just been stored into our mind, and it is unable to express to anyone. So here the mental health problem starts. And why we are using this in tech professional, because the remote work isolation, which reduces the social support, and the irregular working hours, means it is very helpful for each and every person, so that they can deal their mental health and be fit and fine. According to survey, we have seen that 50% of the tech workers are into the mental health challenges. I have used the OSMI survey. I have input, for example, I have just mentioned the theory here. And let's see to the project. The first I have installed and imported the libraries. The second I have imported the CSV file, and the third is I have loaded the data. Then I have done the data cleaning. After cleaning, we have 587 and 25 rows and columns. And the basic EDA functioning means the code I have been written, and here are the three graphs according to the code. The first one is based on the gender distribution. Ma'am, here sorry for the very congested space because the data is in the very low amount, no, so it is just the mixture up there. And the second, we have the age distribution of respondents. So as it is go high, so it is an uh, normal graph. And the third one is the company mental health. Here, yes, no, and don't know benefits we have mentioned. And here I have mentioned the India waves global comparisons. Means, for example, we are comparing the mental health between India and the global. So we can recognize this. The benefits we have seen, it is morely yes, and the seeking help, some of the peoples are no. The next I have done the interactive plotty visuals. So here the graph is just according to the filters we have mentioned. For example, I have seen here female, so it will change. We can see the genders count, and what the information I have just inserted here, and it will just change according to the filter. The graph is changing. Here also the chart is changing on the filters mentioned. As we go below, the chart becomes bigger. And here the very small percentage also we can see. And the third one is the box plot. So here the clustering also, whatever the huge data is into the box plot, and the mixture or for the congested part is just into the small circles, as we can see. And the next is hypothesis testing. Here the first one is for benefits with treatment, which is use the chi-square test, and the second is age treatment, where we have used the t-test. And just I have mentioned the percentage or the p-value here. And the extra insights, where we can see the remote work with the mental health consequences. Means, for example, the remote health, we can see there are no and yes. In comparison, the yes is more, and whereas the mental health consequences are more, means which are negligible, and which is no. Here also the gender view seeking mental health help, we can see they do know and know is the more in the graph. And here the key insights I have just mentioned. Ma'am, can I stop?
Yeah, okay. And you are telling there are certain like congested based on the in the x-axis the datas are whatever be the
Yes,
datas that
ma'am.
are congested there. You
Yes.
can just increase the figure size, then that will resolve the issue.
Ma'am, I just tried
Okay.
it, but due to it is the very small information, no, so the graph is just in the output, it becomes very congested.
No, no, I am saying in the figure size. If you just there you have put, I guess 6,4. There, if you increase by 10, like the width and height, that much if you increase up, then the
Okay, ma'am.
figure will be lengthwise or breadthwise it will increase, and eventually the data will be more like not in a smaller place it
Sorted.
will
Yeah,
cover.
yeah.
It will be, yeah.
Yeah, I
Okay.
got it. Yeah, ma'am. While
Yeah.
submission, I'll do that correction and submit it.
Okay, fine.
Yeah.
Okay, got it. And you have just uploaded this project in your GitHub?
No, ma'am, not yet. I was just
Okay,
working
fine.
on 2 days, and I was out in the morning. I just came in the evening, so I will just do the updation and upload it.
Okay, fine. And I just
Yeah, ma'am.
wanted to
Thank
ask
you.
how many plots you have done, the interactive plots. Can you just let me
Ma'am,
know?
they are three.
Okay, so it would be better if you can count for more, but three is like, see, the data you have chose, how many number of rows and columns are there? Can you just let me know?
Ma'am, I have imported the data like 5 rows and 27 columns.
5 rows and 27 columns. Okay,
Yes, ma'am.
five five rows and 27 columns.
Yes, ma'am. Loaded the data.
But the data is not that like much. Like only 5 columns are there against 27 rows. Sorry, 27 columns. 5 rows only are there.
Yes,
Else,
ma'am. But
how many?
after cleaning, they are
Okay,
587 and 25.
587 rows and 27 columns.
Yes, ma'am.
Initially, how many number of columns are there? You tell me. Not by just by seeing the like dot head. Dot head will give you only five number of rows.
Yes, ma'am.
Initially, initially when you have just have the CSV file, what is the number of rows and columns?
Ma'am, it is the shape of data is 125, 1259 and 27.
Okay, okay, got it, fine. Okay,
Yeah,
so
ma'am.
you have got around after cleaning, it has come up around 587, right?
Yes, ma'am.
And there
Yes.
are 27 rows. So you have more scope to go ahead and see the plots and the correlation among the among the features that are there. So only three plots is not satisfied. You can just check on and add more plots up, the
Okay,
interactive
ma'am.
plots, right?
Okay, ma'am. Yeah.
Okay.
Yeah. Thank you.
Great. So, and Fida, have you just uploaded it in your GitHub account?
Yes, ma'am,
Fida?
I did upload.
Okay, okay, fine. Okay, great. Next is Chetan. So you are ready. So you can just share the screen.
Sure, ma'am.
Okay.
Good evening, ma'am.
Yeah,
Today I
good
will
evening.
be presenting my exploratory data project on mental health in tech professional. So I chose the project because mental health in workplace, especially in tech industry, is a relevant issue. Many employees struggle with stress, anxiety, and a lack of organizational support. And I wanted to explore what the data tells about this problem. So the data set I used comes from the OSMI mental health in tech survey. It contains responses from professionals across different countries, covering aspects like age, gender, company size, remote work, employer benefits, and whether or not the individual sought treatment for mental health issues. So my goal was not to build a prediction model, but simply to explore patterns. So I focused on demographics like age and genders. So, so as you can see here, I have imported the uh, essential libraries, and here I have fetched the uh, data set. Then so here I checked for null values. Then okay, as you can see here, the point chart. This bar chart compares company size. Oh, wait a second. That's, uh, company size with reported mental health treatment, and in this Yeah, heat map. We can see correlation between workplace benefits and mental health outcomes. So here, uh, hello. Sorry, ma'am, my mic was off. Sorry. Hello.
Okay. Yeah, yeah.
Sorry. Sorry, ma'am. Sorry, ma'am. Okay, so okay. In this cell, I have plotted gender versus treatment graph. Uh, so the purpose of this is explore relationship between two variables like gender and treatment, age versus treatment, and in the next one, company size versus treatment. Yeah, we can see in United States the treatment the treatment is high, and in this we can see uh, a peak where in peak in peak here, and then yeah, in gender we can it's not visible clearly. Okay, then I have plotted the workplace factor. Where here we can see where it is. Benefit versus treatment plot. In this, yellow represents benefit and orange represents treatment. And next one, I plotted the remote work versus treatment graph. In this, the same thing. Remote work represents blue and orange represents treatment. Then I have plotted the correlation heat map. It converts categorical values into numbers. Uh, the purpose of plotting this is to spot hidden correlations like uh, employer support versus treatment. And at last, the key insights. Majority of uh, respondents belongs to the age gap group X Y years. Gender imbalance in reporting male versus female mental health reports differ. Remote work remote work has positive or negative association with reported mental health issues. Company with benefits support policies have lower reported treatment needs. Age group less than 25 has tendency to report issues. So in conclusion, I can say uh, workplace conditions strongly influence mental health, and organizations with the support structures have healthier employees. Thank you, ma'am.
Okay, don't just stop screen sharing. You just scroll up. I just want to see your plots once more.
Pardon, ma'am.
Can you just scroll up? I just want to see your plots once more. Okay, okay, okay. Got it. So it was okay. The thing is, uh, last Friday, aren't you there in the session?
I was there, ma'am.
Okay. There I taught how to put in the interactive plots, right? So you haven't put any interactive plots up here, right? You have just visualized the normal plots. It was okay, but I told you, right? If any EDA project is there, it would be better if you can go ahead with any of the like interactive plots like plotly, like you have seen the seen Feda showing, right? Her presentation. There she used many interactive plots, right? Okay, not an
Okay.
issue. Henceforth,
Okay.
keep it in mind and try to like that is for your betterment itself, right? That will create more like efficiency as well, and also uh, like engage people more, and also help you to make others understand, right? So okay, fine, Chetan. So the thing
Yeah,
is,
ma'am. Sorry for the inconvenience.
okay, not an issue. Fine, you can just stop your screen sharing.
Okay. Thank you, ma'am.
Yeah. For today, we can't conclude like take up more students' presentation for today. So Soumya is left. Next, next who is left? Like Sajuruddin is left, I guess, and Dikshan Sharma is left. So tomorrow you can present accordingly, okay? And the thing is, I just wanted to ask, like, can you just raise hand? How many of you haven't presented first week project yet? Like, you didn't get a scope to present the first week's project. Just raise your hand, okay? Okay. Only five of you, okay? Any more? Okay, okay. Only eight of you are left, or anyone else? Okay, nine of you. Fine. Okay, so do one thing since it is not possible, right? Since uh, 1 week has already been done, we are down with the second week. So it would be important that you do one thing. You, as I told previously, you do the same thing. You just open up your Zoom, okay? Record like screen share, do the screen sharing, okay? And record your video explaining the stuff on your project, okay? And just upload that video in your Google Drive and give us the access to see it. Like you will get, if anyone having the link will be able to see it, make it like that, and just paste that link and give it a video presentation submission on the first week project. Keep it as a title or the subject of your project, like subject of the mail, and attach the give the link, paste the link accordingly, and share in the same mail ID where you have submitted the project. Fine, guys. I guess 11 or 10 of you haven't done, so do it like this, okay? For this week one project, fine. And now just remove this. Like you can just stop raising your hand, okay? Pranay and Sai, yeah. You have anything to say, or else you can just stop your raise hand this stuff, okay? Okay. So next is I just wanted to ask how many people are new. Just like today is their second or third class, like that. Just raise your hand. Three, four. Okay. Only four of you, right? Okay. So the thing is, the drill is, let me just let you know. I will be showing what is the like per week, what is our agenda and how we are proceeding. That I will be letting you know before starting off with the session. So for you people, I guess the project has already been given. Like, are you like anyone can switch off the mic? Hasini, you can just switch off the mic and let me know. Are you been given with the week one project list?
Yes, ma'am. Yes, ma'am. We got it in the group.
Okay, you got it in the group. Okay, fine. So take out some time in between. And have you done the second week project, this week project? Have you done?
Not yet, ma'am. But because I don't have any idea, like I have to learn something and do that
Okay,
project.
fine, got it. Fine, got it. Fine. So you can take your time as of now, like try to analyze. Like for this week, we will be going ahead from the very scratch. So I guess for this week project, you will be able to like able to understand what you have to do because we will be starting. Like this week has only started, so you'll be able to match up. And in between, like what is the agenda that I am showing you? Okay, per week agenda, what we have done till now and what we are supposed to done in the upcoming weeks. So I'm just sharing the screen. You let me know is it visible or not. Fine.
Okay, ma'am.
This is basically for the newcomers. Okay, it is visible, right?
Yes, ma'am. Yes, ma'am.
Yeah. So for the first week, we have just gone ahead and done some of the basics of Python. How we can include Python, like what are the basics, loops, how we can do, and along with that, we have done the maths that is required, basically probability, statistics we have done, and also the hypothesis testing part we have covered in the week one. Week two, we have gone ahead with the visualization pre-processing so that we can perform any of the ED analysis. So data cleaning, pre-processing, feature selection, this part we have completed in week two and also with the EDA project. Next, week three, we are supposed to do with the supervised learning mechanism. Like what is the supervised learning, how we are supposed to do it. In build, like in a session only, we will be trying and learning how we can do the training and testing, cross-validation. This part we will be covering along with the scikit-learn. Fine. And next week four, we will be covering like the similar week three, it is for supervised. Week four, we will go ahead with the unsupervised part along with the model tuning and stuff. Week five, we will be converting, like covering the neural network, CNN, ANN, along with the deep neural network specifically, like perceptron, activation layer. This all we will be covering, back propagation. And week five is basically on the project and deployment part. So this is actually how we have to go ahead. So it is clear to you, like the newcomers, what is the agenda per week. Actually, first week and second week stuff we have already completed. So this is the third week going. So this week we will be starting from scratch about the supervised learning, machine learning basically. Clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, fine. So, any doubts related who have come late, any issues, anything you want to know about anything? Okay, Pranay,
Ma'am,
you have anything to? Yeah, after the projects.
after the project submission, can we directly submit it to the mail ID with our presentation,
Yeah,
like
as
about
of
the
now,
weekend project?
yeah, definitely. So it would be like that. You have to submit the project because from here, there itself, your evaluation would be done, and like whatever be the further proceeding related to certification and all that will be given. But you need to submit the details, like submit the project. Okay. So for you, as I mentioned, the presentation would be like you will be opening your Zoom, present your screen with the presentation or the code that is there. Along with that, you will switch on your mic and the camera and will present. Okay, you
Okay,
will be
ma'am. Thank you.
presenting along with that and record it. Fine. And also, whoever is left with first week presentation, they will be doing it like
Ma'am?
that. Uh, just a minute, Pranay. Just a minute. I will be coming
Yes,
to
ma'am.
you. Just a minute.
Yes, ma'am.
Yeah. So whoever is left with the same stuff, like left with presenting first week project, they will be following the same drill, like putting it into the putting it into the Zoom, record your video, keep your mic and camera on, present your screen, record the session up, and then upload it into your Google Drive. There, give us the access so that we can view your video. Along with that, in the same mail ID, mini project, that mail ID, you have to give the like attach the project, like first week, like mention it, which project is it? It is first week video presentation, video link like that. You put it and send. Fine. Clear, guys? Everyone, this much is clear. What you have to do?
Yes, ma'am.
Okay. Now, Pranay, you tell whatever is your issue. Clear
Ma'am,
everything? You have anything
I
to say? Yeah.
Friday, my
Yeah.
first session was on Friday. So, ma'am,
Okay.
I have to watch old videos, then do the same.
Yeah, yeah, definitely. You have to submit week one, week two project. So that is mandatory. Okay.
Yes, ma'am.
So you can ask
So, ma'am,
the
can I take
HR.
my time?
Okay, I guess, yeah, as of now, you can take your time because you have just joined. So, but henceforth, since
Yes,
from
ma'am.
today, the new session, new week is coming up. So, based on that, for this week
Yes,
project,
ma'am.
you have to submit on the deadline that will be given to you.
Okay, ma'am.
Okay, okay. So, we'll just start off with today's session up. Okay. So, today, basically, we will be covering up. The basically we will be going ahead with supervised learning. So I guess you all are aware of supervised learning, right? What is supervised learning, right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. It's not for only the new people who are there in the session. It's for everyone, like Feda, Aditi, who are there already in the session. It's for everyone. I asked the question to everyone, all 42 people who are there in the session. So try and answer. Okay, guys. Like answer in the sense, try and interact because this is a supervised learning we will be covering. So we'll try to keep it interactive because you people also have some idea about supervised learning. So tell me what you know. Eventually, I will be telling you know my viewpoint. I will be putting. So try to be like that. Like try to make it like that. Since in the very first session it is supervised, we need to understand what is supervised learning. We have nothing to code as of now. So we'll try to keep it interactive. Guys,
Ma'am, when
no
a
one is
model is
here.
trained on labeled data,
Yes, absolutely. Anything else? Anything else you want to put in?
it learns from the data set or we are providing it. It has features or predefined labels.
Okay. Okay, great. So see, my screen is visible to you. See, since it is, we will keep it interactive. I have nothing to present like that. So basically we have taken it down. Like if you want to learn it better, you can there are many websites, there are W3 schools where you can take it down, or also gig for gig there. There is more structured way you can get it. Like if you want just the theory part, want to read the theory part, or any of the book also you can consider up for learning this part. So here for learning and understanding supervised learning, we'll try to keep it interactive between us. It's like we are discussing among ourselves what is supervised learning. Fine. So from my end, I just wanted to put in like it's like supervised learning is like teaching a child, you can think of like teaching a child with some examples, some answers. Like you must have seen me when I am trying and explaining you anything, I give you some of the examples in the form of code or anything. If I have any examples certainly in mind, I try and give it to you, right? So supervised is learning is also like that. It's like teaching a child with the help of examples or answers. This answers is basically called as labels. Okay. So whatever be the answers we are considering up here is considered as label. Okay. So basically the method comes up like this. We have the input. That is the question, that can be the situation, that can be abruptly anything. Okay, basically the question is come into the input part, and the output that is to be correct, that is the answer or the label. Clear, guys? Understood this much?
Yes, ma'am.
Yes, ma'am, understood.
Where are,
Yes.
yeah, where are others? Why people are not responding?
Yes, ma'am.
Okay, did you understood what I told?
Yes, ma'am.
Yes, ma'am.
Fine, got it. So, you have anything to put in from your end, Aditi,
Ma'am, on the
about
topic of
supervised learning?
clusters.
Not clusters. Clusters is now not have came yet. I am asking about supervised learning. Aren't you there in the class?
Yeah, ma'am, I'm there.
Uh, so, you have anything to put in about supervised learning? You know what is supervised learning?
Yes,
If
ma'am.
you don't know, that's fine. Okay. If you know, tell me what you know. Because as I told, I want to put this session because it is not anything technical I have to show. We have to just interact, right, with about supervised learning part. So you can tell me, Aditi, what you know
Ma'am, in
about supervised
supervised
learning.
learning, we just train the model according to our need.
Our need. Okay. In every model, we train the model based on our need only. It's nothing different. In unsupervised also, we train the model based on our need only. It solves the problem that we have actually. Okay, not an issue. The thing is, as I mentioned, yeah, Fida, you have anything to tell?
I know something about supervised learning. Am I allowed to
Okay,
tell?
please. Yeah, definitely.
So the model will be given input and output both by our side.
Input and
It's the
output both by ourselves. Okay, next.
label data we give them, we give the model.
Sorry, your voice got broke. I didn't get you.
The label data we train the model on.
Okay, fine. Okay, fine. So let me just elaborate the things up a bit. So let me just give you about, okay, this is not actually the stuff. It was related to clustering actually. So actually we don't need the slide or presentation. So it was like we are trying and keeping it interactive only. So basically in real time, if we have to see about supervised learning, the thing is you can think of about a teacher and a student. Like imagine a teacher showing like they are showing suppose the flashcard of animals or flowers or fruits to a child like nursery or any kindergarten student to make them know how what actually the stuff are, how actually the things look, right? Because kindergarten students or lower nursery, upper nursery, the students are really small. They don't have any proper idea how what looks like. So they give a picture, like the teacher shows a picture, and against that they name the picture. Suppose a teacher showing a picture of an animal, maybe a fox, and also labeling it or giving it a name, that is this picture is of a fox, right? So in that format, that the child is in grasping or understanding that this, when I see this picture, of a fox. Similarly, they can see a picture of a cat, dog, basically, and based on that, they get the label. This picture is of a cat, this picture is of a dog. So basically, what we are doing, this flashcard image that the teacher is showing, that is an input. That is a feature actually. The animal name that the teacher is telling to the children is the output, or that is the label you can say. And the children or the child who is learning from that, that is the machine model who learns from the data that has been given to it. So, understood everyone what is supervised learning?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Yes, ma'am.
Okay, got it, fine. So we are going ahead with supervised learning types. So we do have two types of supervised learning that is further classified accordingly. That is classification and regression. Okay. So anyone have idea about classification? What classification is?
Classification model basically predict discrete labels or in a categorical data like yes and no. Like if we are building a loan approval model, it will predict only yes, your approval, you are approved, you are not approved.
Okay, okay,
Maybe
got
fraud
it.
detection, spam, not spam, yes, no.
Right. Yeah, definitely. Yes. So as as he told, Dikshant, right?
Yes, ma'am.
You told, right? Okay, fine. So as Dikshant told, so it is like this itself. So classification, what classification is? Classification is like grouping. So you can think of when we are like when you using the output. I told you like the animal name previously, the example that I have given to you, where the against the flashcard image of the animal, there is an animal name. Animal name is the output, right? So here for classification, when the output is categorical or there is a class between the output, like as he mentioned, yes, no, is it a dog or a cat? Is it a pass or a fail? Or is it a spam, not spam? This type of categories is building. Then we are calling that sort of problem as a classification problem. Okay, so here you can see there they have given a classification example of dog versus cat. So here feature one has been uplifted and feature two has been uplifted, and accordingly they have plotted it down based on colors, texture, and shape basically. Okay, so let me just give you some example about classification. So in case of classification, we can consider about email filtering, like input, like email filtering, like the email that we are getting that is spam or not spam. So in input, what we are getting in input, we are getting the mail email text. Whatever be the email text that we are getting from the input, and in output we are getting either spam or not spam. Got it, guys?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, great. So next example we can think of medical diagnosis. If in the input what it we will be getting, anyone have idea about medical diagnosis? What would be the input and what would be the output?
Like the blood sample, based on that, we can be
So,
getting the disease out, like whether we have any disease or we have stable health
right,
conditions.
exactly. Great, yes. So
like
in case of
cancer.
medical diagnosis,
If we feed the
is it?
okay, can I say
Uh, yeah, yeah, definitely. Sir.
like if somebody have cancer or not, we can use images, labeled images, and put that into the model, and it can predict if the person has cancer or not.
Yeah, okay. It is true for brain tumor, right? I don't know whether it will be there in your project or not, like henceforth project, second year, like this week project or not. But like there is brain tumor, like the MRI imaging project, like that is, don't take it in the project sense, just in the form you can think of. In case of medical diagnosis, MRI images can be given as input, and in output maybe we can get if like if the person, based on the person we are getting, the person has tumor or not, in that format. Okay, in the similar format we can think of an exam result, right? where the input will be the student's marks, whatever be the student's marks is there, that is put into the input, and in output we are getting if the student is passed or failed. Okay. In the banking sector also we can think of, suppose there is in input we can think of about the customer details, whatever be the customer details that are there, we can think of it as an input. And in output we will be getting if the loan will be approved to the customer or not approved. So this is actually like actually classification kind of problem where we are getting categories or classes in the output. Clear, guys?
Yes, ma'am.
Yeah,
Yes,
ma'am.
ma'am.
Yes, ma'am. Ma'am.
Okay. Okay, great, great. So we can think it of like deciding with bucket of items belonging to, right? So we can definitely think it of like we have two choices based on the input it will give, which would be the correct option, right? So similarly, we can think of about regression as well. So anyone wants to put in any idea about regression, what regression is?
Yes, ma'am.
Can I?
Yeah.
For the regression,
Uh,
we will be working on the continuous values. Like example, we can
yeah,
consider the predicting the house prices, where we will be
right.
giving the input features like the number of bedrooms or the location, the square feet area of the house. Based on the location and all, we will be getting the pricing of that house.
Great. Okay. Right, Hashimi. Anyone else was about to say? Please tell.
Like stock price prediction,
Yeah,
where we use
of
the
course.
past data of stocks, and we try to predict the future price of stocks.
Yeah, definitely, of course. So, in case of regression, also what we are doing, prediction we can definitely refer to as predicting numbers. Okay, regression is equivalent to predicting numbers, and in case of classification, what we are doing, we are sorting into groups or presenting it into groups, right? But in case of regression, it is predicting numbers. So it is used when the data that we are having is continuous or the output that we are getting is continuous, as Hashini told, right? So here, in case of classification, we are getting into categorical data. In case of regression, we are getting into continuous data or continuous numbers in output. So as example, we can think of, yeah, Abhishek, your voice is breaking. I'm not getting what you're telling.
Bro, your voice is breaking. You just try to reconnect.
Abhishek, I'm not getting what you are telling. You try and reconnect. Okay, I guess he doesn't have anything to say. By fault, the mic might have kept on. Not an issue. Okay. So, for example, we can think of about house price prediction, right? So, as Hashini mentioned, house price prediction. So, what we do in case of input, what we can take as house size, location, number of rooms, number of square feet. This data we can take, and in output what we will be getting the price, what is the price of the house, and we it is not categorical, right? The price can be 1 lakh, 5 lakh, 10 lakhs, even 1 crore based on the criteria or the input that we have given on. So the input what we have given on the house size, what is the location, is it under any posh region or like nearby slum area or in a normal locality where like no posh things are happening, or how many rooms are there, is it a 1 bhk, 2 bhk, 3 bhk or 4 bhk, how it is. So this is the input that we are putting against the label, like against the statement of house price prediction. In this context we are putting this as input, and in output we are getting the price, that is the what can be the absolute price we can think of, or the abrupt. Yeah, Fida, you have anything to say?
Sorry, ma'am, it happened by mistake.
Okay, but why you people do all this? Like, try to, like, I understand, but when anyone is saying, right, the person is in flow, even in your presentation also, if anyone speaks, right, you just lost the flow, right? So try not to do it. It's a humble request to you. Okay. So next we can think of about a weather forecast. Okay. In case of weather forecast, what we can put in case of input, you can tell me anyone?
Ma'am, in
I'm
weather
The
like
forecast,
wind
humidity,
like
speed,
rain conditions.
temperature, humidity.
Yeah,
wind
definitely.
speed.
Definitely, yes. This all we can put it in case of weather forecast like temperature, humidity, wind speed, as all of you told. And in output, what we will be getting? Anyone?
We're getting a
Some
prediction
rainy,
like today is rain
rainy.
or rainy, sunny, like that.
Yes, yes, right. So we will be getting either the temperature, like is there any specific temperature that is followed today, any specific temperature that is getting followed, or is it raining, thundering? What kind of raining? Is it just pouring? Is it pouring heavily or thunderstorming? This kind of data we will be getting. Or basically in case in continuous form, if we are thinking of, we will be definitely getting the degree, like the temperature, how much it is, how much temperature is it outside. So this kind of data we will be getting in output. So in case of stock price prediction, another example we got in today's session also. So stock price prediction, there what we will be getting in case of input, we will be getting the past stock that we will be taking, the past stock values that has been considered, that we will be considering the market condition, how it is in the market. Is it trending? It is not trending, going down, how the stock is in the current market scenario, that we can think of. And in output, we will be getting maybe the next day prediction of the stock, next day's prediction, or uh, like what would be the stock price for the same stock we will be getting for the next day. As a prediction, we will be getting it like that. So we can conclude that regression is basically for prediction purpose. We are been given with some of the values, some of the data. Based on that data, what regression model is just doing? Regression model is going into deep, trying and understanding the analytical trends that are there or the hidden patterns that are there in the data set, and based on that try to predict the very next talk that we are like very next like data or the output or the things that we are asking as output, that will be given to the regression, that will be given as output by the regression model. Just a minute, guys, excuse me. Yeah. So basically, what it does, it basically in case of regression, what it does, it is predicting how much or how many this thing will is being predicted by the regression model. Okay. Next, we are coming about like trying to understand about some real-time example of supervised learning. So, anyone having any idea about any real-time or real-life example of supervised learning? Anything coming to your mind?
Ma'am, spam email detection.
Yes, that is into classification. I am asking about any real-time, like real-life supervised learning you can think of that is already existing.
I'm
Okay,
like
like
reinforced
self-driven cars.
supervised reinforcement learning. More like today's most AI used supervised reinforcement learning to train itself on the user's input.
Yeah, that is fine. I am asking about a real-life example. Like we can think of self-driven cars, right? we can think of self-driven cars. You are well aware about the self-driven cars by Tesla, right? So, what is the input we are getting in self-driven cars? We are giving input like the camera image. We are giving input of the roadside. So, in output, what we are getting the output, the AI model is basically telling when to stop, what might be my speed limit, or what is there any no entry, no parking zone, or how like how much distance is another car is there from my end. This all are we are getting as output, right? So real time example we can think of as self-driven cars. We can think of a voice assistants like Google assistants, then
Like on
Siri.
traffic
Traffic.
signals also work automatically using AI.
Yeah, there are some regions where it is using, but not all region of India. It has been mentioned in like that format. Nowadays,
Like
also
we
we
see
are seeing
in other
numbers.
countries,
Yes,
they use automatic AI
yes,
systems
yes.
for traffic.
Yeah, yeah, definitely. Yes. So we can think of voice assistants as mentioned. So there, what we are putting, we are the input is our audio or the voice that audio recording or any of the voice. We are just but in real time we are telling to the device, and in output we are getting any text command, maybe any music it is playing, or if I tell call mom, the person is like it is the voice assistant is helping me to call my mom, right? So it is in input, it is my voice, my sound actually. Okay. And in output, we are getting any text command, or basically we are getting any output, or any action has been done based on my instructions. So this is voice assistance. Next, we can think of credit card fraud detection. That is a huge project where people are taking into account about in input. We are getting the giving the transaction detail like the amount, location, how much is the money or the time, and in output we are getting is it is a fraud or a genuine. This kind of things we are getting in real time. Also, movie recommendation. Yeah, Pranay, you have anything to say?
Rocket
Sorry,
during rocket launch, I think we also use like this.
rocket launch. What you we are using?
I'm like we are
Like
giving some
how
input, then rocket launching happens like that.
I like they
Okay, yeah.
measure weather conditions.
Yes, yes, exactly. Yeah. In case of rocket launching, there is certain technique where we are just like seeing what would be the weather forecasting we are seeing, some of the real time based things we are taking into account, or also measuring and checking the condition of the rocket and stuff. Yes. We can think of about movie
Yes, ma'am.
recommendation, like Netflix, we can think of, we input what input we are giving in case of Netflix. We are putting like our past watching history, we are putting into count. And in our output, what we are getting the like the rating based output generation we are getting, like predicting ratings or getting any kind of genre in which I am more used to seeing the movies or I like to see the movies. So what the model is doing, it analyzing my past watch history and try to find any hidden patterns or hidden trends that is there in the data that I have given to the system as input. And in output, the person, like in output, the model is recommending me new or my anything that is relevant to my knowledge or relevant to what I want to see, the movie names like this or maybe the ratings also. Okay, clear guys? Understood?
Yeah, ma'am. Yeah,
Yes,
ma'am.
ma'am.
Okay,
Yes,
Got
yes,
fine.
ma'am.
Okay, great. So, in analogical point of view, if I want to say about classification, so that one keeps it in mind, I can think of like imagining a basket that has labels of apples and orange, right? So when you are showing, like when I am having a suppose I am having a basket and I am having apples and orange mixed in that very basket. So whenever I am showing you one apple, so easily you people will be able to understand like this is an apple, this is not an orange, right? So when you are answering that this is an apple, this is making a decision. That is actually the output that you I am getting from your end. But this I am telling you in an analogical point of view. But this thing will be happening in case of model. Like we will be giving this data or the pictures of apples and oranges to a model to understand and learn. And it will what it will do? It will understand like the color. It will analyze the color. The red color is basically of apple. The orange color is basically of an orange. The shape of the apple is how the shape of the apple and what is the shape of an orange, what is the texture of the peel of an orange, what is the texture of the peach like the peel of an apple. The model will try and analyze among itself and try to find this hidden patterns or like how to put into through and best when after it gets trained, when I will be asking giving any of the apple data to the model, that what it is the based on the understanding and the training, the model will answer me. So if the answer is correct, then the model has trained well. If not, then the model needs to be trained accordingly. Right, guys?
Yes, ma'am.
Understood?
Okay, ma'am. Yeah. Yeah, ma'am.
Yes, ma'am.
Okay.
Got it.
Yes, ma'am.
Okay, fine, great. So we'll continue with the session from like from here, from yesterday. But as of now, you people have anything to ask, you can tell me. Any queries, anything relevant to it you want to ask, you can definitely tell me. No questions, nothing.
No, ma'am, I'm
Ma'am,
good.
based on the project presentation itself, we'll be getting the certificate, ma'am, for the internship.
Yes, there are certain rules, I guess, in the mail itself, it has been mentioned. So, yes, project is a very vital thing. You need to submit all your project that would be evaluated, and also your performance in the class and your interaction in the class. All of this stuff will be taken into consideration, and also your attendance. Attendance is mandatory. Like that is the prime or like one of the prime things.
Okay, ma'am, thank you.
Yeah. Anything else? Anyone?
No, ma'am. Everything is clear.
Okay, got it. Fine. Okay. Then accordingly, I guess yeah, recorded session has already been given to you, right? So you can see accordingly the recording, and based on that, who are new, you can just go ahead and see from there the recordings, and accordingly go ahead in the classes, do the first and second week project, right? And submit it in the like the same mail ID that has been given to you. And rest people, I guess you are clear, right? How you have to record the video, presentation video and submit it, right, guys?
Excuse me, ma'am.
Ma'am, I have recorded a Zoom
Yeah.
video, but only voice was recorded.
Sorry.
I
In
recorded a
Zoom.
Zoom video, but only
Yeah.
voice was recorded.
No. I have already done this. So when you will be seeing three, there will be two files that gets converted like after you end the session, right? So it takes time to convert. You allow the time to get convert, okay? So after it's done, so there is two things that get recorded. One is video based thing, another is only the audio. So you have to submit the video along with the audio, okay? So you get two
Yes,
files
ma'am,
up.
that, but
Yes,
that video
the video.
is blank, like nothing. that I have done with that file is not recorded in that video.
But how can it happen? It happened for me. Like I did it multiple of times, and it happened beautifully. Like it generally Zoom does gives two files in the recorded session. One is only the voice recording, and another is the video, voice, screen presentation, everything. Everything is there. So you need to check which file it is. I guess you have misplaced that file. You just check it. Or if not, Zoom, you can use Loom or any other platform where you can record and present the screen, any of the platform like that, you can find out and record the video like that, and just as I mentioned, put it in the drive and share the drive link.
Like
Yeah.
you,
Okay, ma'am.
Yeah,
can I
Priyansh.
say something? Like you
Yeah,
can
yeah,
use
definitely.
OBS to you can
Yeah,
use
yeah,
OBS
definitely.
Studio while on screen. It helps you to record your
Yeah.
screen on like screen or desktop.
Okay, okay.
It's best for free. Just
Yeah,
connect with your
you
like
can
if
use
you are
that.
from Zoom or Google Meet or Team, connect with that from the website.
Okay.
Yes. If not, you can also try in like Zoom once again because it worked fine for me. You can try. If not, you can definitely use any other platform. There are multiple of platform. There is Loom also is there. There also you can use. Okay. So accordingly,
Okay.
do it. Yeah, accordingly do it and submit it. Fine. Clear, everyone?
Ma'am,
Ma'am, I do
Yes.
have
Yeah.
one query about my project.
Okay. Yeah, Aditi, tell.
As you said, to add me more graphs, minimum or maximum, how much should I add? Currently, I have three.
That's what I told. You can add three, four more because there are, I guess, 27 features you are having, right? So
Yes,
you
yes.
have more scope. Like you need to build the project as if in a professional way. You need to build the project. So three graphs based on the based on the features that you are there, your data set is actually having. I guess it is not enough. So you try and add more more 5 6 visualization or plots. Okay.
Okay, ma'am. Yeah, got it. Thank
Yeah.
you.
Yeah. Okay.
Ma'am, is there any group where we can collaborate each with each other?
I don't think so any group is there, but I am not sure of, but I don't know actually if there is any
Because
other
it's
group
better if
or
we
not.
collaborate with each other, like we understand the each other's project, each other's intention, like why we are building and what we are doing in the project in current time.
Yeah, I understand, but as of now, this projects are single projects only, okay? And it will be evaluated also. So it would be better that, like, it's better if you can communicate among yourself, but that is a different point. And making the project and discussing the project, that is different thing. Because based on your project, only your performance will be evaluated. So that is another key area you need to keep in mind.
Okay.
Yeah.
ma'am, for
Yeah.
the new joining people, should we need to submit both the week projects, week one and week two?
Yes, 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 yes.
Okay, ma'am. Thank you.
Okay. So from this week is a continuous, like when you joined, can you let me know?
The last Friday, ma'am.
Last
Friday.
Friday. Oh, okay, okay, fine. Got it, fine. So this is a new week altogether. So since today the topic was supervised, so I tried and keep it interactive. Henceforth, when we will be deeping, like go deep into the topic, we will be going ahead and doing the coding and stuff in the collab file itself, right? So that would be helping you to understand the stuff more clearly. So since we need to understand what supervised learning is, that is more of theoretical part. There is nothing to code. So I tried and give you simple examples to make you understand what actually the stuff is. Right. So henceforth, well, we will be going deep down with the topic. We will be using the collab file and seeing. Like last Friday, you might have seen we have done one EDA project, right? So there I have shown everyone about the how to use this interactive charts. So same way we will be doing here. Okay.
Okay, ma'am.
Yeah. So okay.
Uh,
So everyone's doubt is clear. Yeah, Priyansh.
Also, when you use Collab, you have access of Gemini. You can ask anything about your project, like where if you stuck somewhere, you can ask to Gemini, explain me this and like that.
Yeah, that is there, but yeah, if needed, anyhow, if it needed, you can definitely use that.
Like it's only
So,
related to your
what was
project
your
when you are working
question?
on the Collab workspace.
I didn't get your question, Priyansh.
I mean,
Are
when
you telling?
like when we okay.
Yeah, 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 yeah. Please tell. Tell, I'm listening to you.
Okay, ma'am, I was saying when we are building project inside of Collab, Google Gemini knows what we are doing and what we are working on, so you can ask follow up about your project
Yeah,
to better
yeah, that is
understand it.
quite simple. Yes. That you definitely can do. Yeah, anyway, if you are getting stuck or if you are getting any issues or bugs in the code and you are unable to solve it from your end, you can definitely ask. Okay,
Because
so I think
I've
all.
seen some people who only attend the session and ask the question only on like sessions. They will not use AI, so I think it's not a good thing.
Okay, both are fine because, like, if, like, yes, it is good to use AI, of course, but in the session, if anything you want to ask, like, get answer from or anything, what I have told you, you want to get, like, you have any doubt on, you can definitely ask me, not an issue on. And while building your project, because I won't you have to build it all alone. So you can definitely ask Gemini or also use, I guess most of you are using ChatGPT to do your projects, right? So it's okay, not an issue. But it would be good that you learn from that, not just copy pasting, right?
Yeah, ma'am.
Yes, ma'am.
Yeah. Okay, clear everyone. So we'll just wrap up our today's session here. We'll meet tomorrow and continue from here. And I guess according to the list, I guess Soumya is left. Soumya will start with the presentation tomorrow. Fine?
Okay, ma'am.
Okay, ma'am.
Yeah. Yeah. Okay. Bye bye. Bye, guys.
Bye everyone.
Thank you, ma'am.
Thank you. Bye bye.